So this video is going to involve using our spectrophotometer to determine the concentration of nucleic acids. So if you do a mini prep, you might want to know what the concentration of that is. If you've purified a PCR product or a digest, you will probably want to know what the concentration of that nucleic acid is. And so we have this machine in the lab. Here, it's back here on the DNA gel bench, called a spectrophotometer. And it has a little, I guess you would call it like a pedestal, where you can put your sample. And then a light will shine through your sample and evaluate the concentration of nucleic acids in there based on absorbance. And so I'm going to try to do this by myself. It's taking, usually I do this with two hands, but I'm going to actually try to flip you around to show you how to do this, and hopefully it will help. Okay, so the first thing you want to do when you come over here, you might need to take the dust cover off, and you may have to wake up the screen, which you can do just by touching the screen. And then you're going to open this part up to expose the pedestal. And then the first thing you want to do is to just add a little bit of alga water, that's just ultra pure water, onto the pedestal, and use a chem wipe to wipe off both the pedestal and the lid. This should be done before and after your use of the spectrophotometer. And the next thing you're going to do is choose your method. We're going to use nucleic acids. And it's going to give you an image like this. At the very top it will say double-stranded DNA, which is what I'm going to be taking the concentration of, but you can change that by touching it if you are trying to quantify another type of nucleic acid. As it says, you can add 1 to 2 microliters, and it will give you the concentration in nanograms per microliter. Before you add your sample, you need to add a blank. And this just means adding a sample of whatever buffer you're using, so that the machine knows kind of what the solution is like without your DNA or RNA in it. So I have mini prep samples, so I'm going to use my elution buffer here. That's my samples there. And I'm going to take a 1.5 microliter sample of the elution buffer. And then I am going to, this is hard to do, pipette it directly onto that pedestal. I don't want to add any bubble or anything, but I want to get the solution onto that pedestal. I'm going to close it, and then I'm going to hit blank. And the machine will just send light through that solution and normalize, so that whenever you have your nucleic acid sample, it will subtract out any absorbance that was present in your blank solution. I'm using elution buffer because that's what my mini prep samples are in, but if you had your samples in water, you would use water for this. And I always use the same water, so you don't want to use RNase-free water to elute something and then take some sterile water or water out of the sink to do your blank, because those would be different. So now I'm going to take my first sample. You'll use regular tips for DNA or the RNase-free tips for RNA. And I'm just going to pipette that sample out. And then again, pipette directly onto the pedestal. Okay. You're going to close that again, and this time instead of hitting blank, you're going to hit sample. And this will tell you a few things. First of all, this will tell you what the concentration is. So this is 550.45, so that would be 550 nanograms per microliter. This also gives you a curve with the absorbance on the y-axis and the wavelength of light on the x-axis. And so you can see one nice peak here, which is the absorbance of DNA right around 260. There are also two values here, 260 over 280 and 260 over 230. We actually like for both of these to be at or above 1.8. You can see that for mine, the top value is 1.87, but the bottom value is a little bit under 1.8. That's okay, but we'd prefer to have it above 1.8. And what those values tell us is how much we have of our DNA relative to other types of impurities like RNA or protein or different chemicals in the solution. And you can sometimes get a 260 over 230 value that's out of range a little bit because of some of the chemicals that are in the mini prep or purification kits. So if you did a purification and one of your purity values was around 1, I would probably redo this and talk to someone about what you might do differently next time. Or likewise, if you saw that you had a peak but there was a shoulder or a second peak, you could check that out. So this for a mini prep is great. This is the concentration I would use to determine how much of this mini prep to send for sequencing or use for other applications. If you were using this for RNA, some of these values would be different and would have different meaning. This is something you could talk to someone about if you want to use it for RNA quantification. And so that is about it. After you're finished, I have a bunch more samples to go, but after you're finished, you would wipe this down with the chem wipe, and you would do that actually between every sample as well, so between the water and samples, and then at the end you would wash it with alga water again like you did at the beginning. And that will be that.